So what we've been talking about so far, we've talked about all of our finance, and we talked about interest a couple weeks ago. Then we started talking about annuities as well. So finance is made up of two parts, interest and annuities. We're on the annuity part of it. And remember, an annuity, we back up just a little bit. An annuity is just is a sequence of equal periodic payments, right? So as we're talking about equal periodic payments. And when we do this, we've already learned how to calculate the future value for an annuity. So we've worked on so far. We also talked about calculating the payment for an annuity. And I think the last example we got up to was going to be the present value of an annuity before we stopped. Yeah. And we also talked about calculating the present value, basically loans. So now we're going to do some examples with present value. And in particular, present value, a lot of present value talks about retirement and type of loans. Because in the retirement, what you do is you put away money for a certain amount of time. And at some point, you're going to withdraw that money in equal periodic payments. So it's kind of like you become your own employer where you're paying your own self. That's why you put money away for retirement. So this says an ordinary annuity earning 6.25 interest compounded annually is structured so that a person makes equal annual deposits into the account for 25 years and then withdraws 20 equal annual payments of 30,000, reducing the balance to zero. How much must be deposited annually to accumulate enough money to provide these future payments? And so I wrote this out, A, for me, because sometimes I forget how to do these when I don't look at them in a while. But B, because I also want you to I also want you to realize that when you don't look at it in a while, you might get confused on what we're doing. We need to break this problem down. It's a two-part problem. So what happens is you're going to deposit a certain amount of money into an account for 25 years. And you're going to do that annual. So you're going to make one payment every year, depositing a certain amount, some kind of payment, right? Now, what is happening is after a certain amount of years, what you want to have is when you are basically able to retire, you're going to withdraw from that account $30,000 every year for the next 20 years, right? So assuming that's something like that, let's say that you start doing this when you're 25 years old. So you're going to deposit when you're 25 years old a certain amount of money every year for the next 25 years. So by the time you're 50 years old, I have to have a certain amount of money in an account that now what happens is when I have that amount, I want to be able to pull out $30,000 annually for the next 20 years. So basically from 50 until I'm 70, I want to be able to pull out 30,000, all right? So two steps. We need to calculate the present value of the money first. We needed to make $30,000. So I need to know, remember your present value formula is this right here. And present value works by saying, I want to have a certain amount of money now. That way in the future, I'm able to do certain things with it. So my payments, how much do I have to put into it, right? So this says, first we need to calculate the present value of the money needed to make 30,000 in the following 20 years. How much money do I have now to do this later? Right? Everybody got that? So let's start this. The present value, which we call PV, is equal to, I want to be able to make $30,000. I want to be able to make $30,000 payments. So I'm going to pay this these $30,000 payments. Times the present value formula sitting up here, it is 1 minus 1 plus I raised to the negative n divided by I. Remember what these variables stand for real quick. I is your periodic interest rate, which is the rate divided by the amount of times you're compounding in a year. So if we're doing it annually, I is just going to be your rate divided by 1. And it's the number of compounds you're going to make, the number of compounding periods you're going to make over the entire life of whatever you're doing. So for this particular case, we're going to be doing this for 25 years. We're only doing it one time every year, so we're making 25 annual payments. All right, so let's set this up. So this is 30,000 times 1 minus 1 plus my I here. My interest rate they gave to me was 6.25. So Again, when I set this, I'm going to write it out so you can see what it is, but all it is going to be 0.0625 divided by the number of compounds. My compounds, I'm doing it annually. I'm compounding annually. So my number of compounds is 1. I think we started calling the compounding period M, by the way. So that'll be just R divided by M. And then we're going to find N, which is N is your M times your T. We're going to be doing this for, we're going to do this for 25 years. So there's two T's here. There's one for the amount that you want to get to, and there's one for the amount that you're going to start reducing it by. We want to do this for 25 years. So our T is going to be 25 times 1 because we're doing it annually. So this is going to be minus to the negative 25. So the first part of the formula is completed. The bottom, again, is just I, so it's 0.0625 divided by 1. That's the setup for this. This is the first part. This is going to give me the present value of my money right now. How much money do I have to have now to do this later, the future part of it, all right? So calculating this, remember, I always calculate, I'm going to calculate this part first right here. I'm going to calculate whatever that is right there. So calculating that, I get 1 plus 0.0625 is this. I'm going to raise that to the negative 25 is this. I'm going to do 1 minus all of that. 1 minus this is that. Again, I know how to carry answers in my calculator. If you don't know how to carry answers, you need to probably figure that out, or make sure you write as many decimals as you can. Write as many decimals as your calculator will let you. So I get this value here at the top, 0.7803270.754. I'm going to divide that by the bottom, which in this case is just 0.0625. And I get this right here. I'm going to multiply that by 30,000. Here's my final amount. So here's how much money I need in my account. That present value has to be equal to $374,556, and let's round that up because that's 0.996. So that's $374,557 basically. So this is just 374,557. Here's how much money I have to have in my account to start off with. Before I even start making withdrawals, I need to get my account to this amount right here. So now, once we have that amount, so we know our present value, now that we need, what did we say the amount was? 374,557. So now that we know we need 374,557, now that we know we need that amount, we can find how much each payment needs to be to have a future value of this amount using the payment formula for future value, right? Using the payment formula for future value. And so that payment formula is equal to, let's come back to it real quick. Payments are equal to, this is the future value now. Your future value has to be that number we have there. We want to do PMT is equal to your future value of I, 1 plus I raised to the n minus 1. So I'm using both formulas here. So again, a payment formula is equal to the future value times I over 1 plus I raised to the n. Is it 1 plus or 1 minus? 1 plus, minus in the back. We're writing this. This is wrong. Minus 1. And on your final exam, I'm going to let you have a cheat sheet. So I won't make you try to remember these formulas, but you're still going to pick the right formulas when you do certain problems, all right? But you will have some kind of cheat sheet on your final exam. I haven't decided how large or how lengthy or how in depth it'll be, but you'll have something. So we need to figure out payment formulas. We need to figure PMT. That's equal. We need a future value of 374 557. We know our interest rate already was still I, and our I here is still going to be 0.0625. We're doing annual, we're making annual payments. We're taking out annual payments. So that's 1 over 1 plus I, 0.0625 divided by 1 again. 1 raised to the n. My n this time, I'm going to be making these payments. I'm going to be taking these payments out for 20 years, right? So this is going to change to 20. That's your 20. Right? Minus 1. I feel like I did this wrong now that I'm reading this. You know why I feel like I did this wrong? Anybody want to correct me before I correct myself? I'm just really sitting y'all paying attention right now. Anybody know what I did wrong? I know what I did wrong. Help me out. What did I do wrong?
Is it the payments?
It's not the payments per se. It's the number. Put my ends are wrong actually. This is wrong. It shouldn't be 25. This should be what?
20?
20. And this
20?
one over here should be what? This one over here should be what?
25.
25. Because these are the payments. These are the payments I'm making, right? I want to make how many payments? 25 payments, right? So we need to go back and adjust this. We didn't do a whole lot wrong, by the way. I just messed this number up. So we need to go back and fix that. This should be the 20 part. That should be 20. So I'm gonna go back and calculate the new formula. Just change that to 20. Nothing else is wrong if you followed everything else I did. I just want to let y'all know I realized I did that wrong. So calculating this, 1 plus 0.0625. Raise that to the negative 20th power. Is this 1 minus? Is that times? Here's how much I need to have in that account. That's a significant smaller amount, right? Oh, I didn't do that right. 1 plus 0.0625 raised to the negative 20. 1 minus, that is this, divided by 0.0625. I missed this part. That times, there we go. Notice it's not a whole lot, it's not a real big difference. I mean, it is a big difference. You're doing it by 5 years less, but still, I messed that up. It's $337,221.62. That's what you should have there. My fault. $337,221.62. Let's go back and adjust that number up here then. So these numbers need to change. That is 337,221.62. That means that this number needs to change that too. All right, this makes me feel better. So there. That's how much money I have to have. Times all of this right here. Let's go ahead and calculate all of this. Let's go ahead and calculate all of this right here then. Let's calculate all of this stuff inside of here. So I'm going to do the bottom part first down here.
Professor, change your 20 to 25.
Change that to a, thank you. We need to catch that. Thank you for catching that. That's 25 now. Thank you so much. 25. Because that's how many payments I got to make now. So we do this 1 plus 0.0625 divided by 1 is this. Raise that to the 25th power is that minus 1 is that. And then we'll do the top, which is 0.0625 divided by that bottom part. Carry as many decimals as you can if you're not using your answer key. So I'm gonna carry as many of those decimals as I can. I'll divide it by that. I get this right here. I'm gonna multiply that by the payment amount, by my present value amount, which is 337,221.62, because this is the future value that I needed to get to. There. Here's how much I have to make annually. $5,933.29 annually. These are my annual payments, which, if you think about it, that really isn't that bad. $6,000 annually. I mean, if you got it, do it. So I get I need to make $5,933.29 payments for the next 25 years to reach that amount. Because once I do this, once I make these payments like this, using that interest rate, right, it's going to get me to this future value amount. And now I can withdraw $30,000 for the next 20 years based off of that. This says how much total interest is earned during the 45-year process. So to calculate this, to find the interest, calculate the total money withdrew. How much money are we going to withdraw total? Can anybody tell me that? How much money am I withdrawing total? That's not a trick question, you guys. Help me out with that. How much am I withdrawing total? How much am I taking out? That's how much I'm putting in. That's my actual payments. So I'm actually depositing that. If you think about going to the bank, you're depositing 5,000. You're depositing about 6,000 every year. For how long are you doing? How long are you doing that though? How long am I doing that? I'm going to deposit $5,933.29 for how long? Anybody?
25.
For
25 years, right? 25 years. I got that? But I'm going to take out how much after that?
30,000.
I'm going to take 30,000 for how long?
20.
20 years. So that's the actual withdrawals. So in this particular case, I'm going to take the money I'm taking out, which is 30,000, every year for 20 years. So every year for 20 years, you're going to take out how much? $30,000. That's the withdrawals. So I'm going to do 20 times. I'm going to do 20 times 30,000 here. And when I do that, I get here 600,000. That's $600,000. Now, of that $600,000 that I'm going to eventually take out, how much did I actually deposit into it? Am I with that? How much did we deposit? We had to deposit what?
5,933 and 29 cents.
29 cents for how long? How long did we do that?
25 years.
20 years. We deposited $5,933.29 for 25 years, right? We did that for 25 years, right? So calculating that, that's just $5,933.29 times 25. 5933.29 times 25. Here's how much I actually deposit into the account. I've only deposited 148,332.25 into the account. Got that? So I only deposited this amount in, but this is the amount that I wanted to take out, withdraw. That means that everything else that I'm withdrawing, the rest of this, to make up the difference between these two, is all interest. So to find the interest I, find my interest I is equal to the amount you needed, 600,000, or the amount that we've actually taken out. We're going to withdraw 600,000 minus, right, the amount we've actually deposited, which is so I'm going to calculate this 600,000 minus 148,332.25. Here's how much I'm taking out in interest, which is a crazy amount, by the way. So your interest here is equal to I is equal to $451,667, $451,667.75. What this really shows you, by the way, is that if you are consistent with your payments over a long period of time, the power of compounding will actually grow your money pretty far. I got that? That's what this is really saying. If you're consistent with your payments over a long period of time, then you can make a whole lot of money off your payments. Just so y'all know that. So if you ever decide to invest, make sure if you're investing, make sure you're investing for the long run. It's a long process, but if you do it and you stay consistent and you do all those things, you can make a whole lot of money off of it, just off interest alone. So again, problems like this won't necessarily be on your tests per se, because this is a very detailed, in-depth type of problem where even, you saw how I messed it up for a second there. But what I want to understand is that when you do stuff like this, it has a very practical application to your real life. And a lot of it is you sitting there and thinking about, okay, what formula do I need? Because the hardest part about this is going to be, what formula do I use to get here? And there are a couple forms that you can pick from, but in general, you need to be able to decide which one you're going to use. So you need to be able to ask yourself, what are we talking about here? All right. So now that we've done that, here's another application of the annuity, and it's called amortization. All right. And an important use for ordinary annuities involve borrowing money and making payments on a loan. So this is one aspect of what an annuity does. It's basically an annuity in a real life application again. And you're talking about a loan here. And a loan is an annuity because the money being borrowed now is considered to be the money you're borrowing now. What do you think we call that? Anybody? What do you think we call the money you borrow now?
Present?
Two choices. Present value. Thank you. This is your present value. So the money you're borrowing in a loan is the present value. If you go to the loan, you want to buy a car that costs $30,000, right? And you need to take out a loan for that $30,000. The bank is going to give you a $30,000 loan, possibly, depending on your credit. But still, let's say you have good credit. They're going to give you a $30,000 loan, right? That money you're borrowing now is worth $30,000. Got that? In the end, though, are you really going to pay only $30,000? Yes or no?
No.
No, you're going to pay what? You're going to pay more than $30,000 because you're paying interest on that loan. Does everybody understand that? So the present now is how much you're borrowing, while the person borrowing the money will be making equal, and make what to pay it off, you're gonna make equal what? Somebody fill that blank in. What's that blank gonna be? Equal what?
Payments.
Payments.
Payments. Thank you. So it's equal payments. So we have to make equal payments to pay off the loan for the money that we borrowed now. But you got to make those payments with interest. And so suppose you buy a television for $1,400 and agree to pay for it in 18 equal monthly payments at 1.5% interest per month on the unpaid balance. On the unpaid balance. I want to know how much are the monthly payments, and then how much interest will you pay on this loan? So first thing I need to do is this. I need to be able to calculate I know that the present value of the loan is what? What's the present value of the loan?
$1,400.
Anybody? $1,400. So I know my present value here. Let's write this out. The present value is equal to $1,400. I want to find the what here? I want to find the payments. I know that my interest rate R is equal to 1.5%, so that's 0.015. That's 1.5%, by the way. Everybody got that? My periodic interest rate, I. How do I calculate I here? Anybody want to help me with that one?
It's R over M.
So what is your M? Good. What's your M?
Month.
Try it again. M is
12.
you're making it equal monthly, so that's what? What's your M? I think you said month then. You're right, 12. M should be 12 here. So we're going to divide 0.015 by 12 here. That's going to give me my I, which in this case, let's see if it's a nice number or not. Yeah, we can write it like that. So that's just 0.00125. And what's my N? What's N equal to here? Anybody? What's N equal to? How many payments am I making?
18.
18. That's your 18 equal payments. So your N is the number of payments you're going to make, 18. So here's how the variable's set up in this particular formula. We're looking for the present value. I mean, we know the present value. We are looking for your payments. You have a periodic interest rate of this right here. You're going to make 18 of those payments, right? So when we do this, we need to use the PMT formula, the payment formula. Payment is equal to, I don't remember it off the top of my head. I remember it now. I over 1, is it minus 1 plus I? 1 plus I to the n minus 1. Here's your payment formula. I'm forgetting I need to use the present value payment formula. Let me redo this one. I need to use my present value payment formula. Let's go find that one. If you rearrange the present value payment formula, which I do not have that rearranged for y'all, do I? I have the future value. Let me give you the present value formula. You need it for this. The payment formula for present value. I gotta look it up. I ain't gonna lie to you, I know it off the top of my head. It is that's the present value. I want the formula for payments. All right, it is I over 1 minus 1 plus I raised to the negative n. PV, I'm sorry. I keep forgetting to put the other part in front of it. This is present value times that. Put that in there. So with that in mind, let's go ahead and calculate this now. So your present value is, the payment formula for this is PMT is equal to the present value, 1400 times I, which in our case we already calculated it to be 0.00125 times 1 minus 1 plus 0.00 raised to the negative 18.
I'm sorry, can you explain the 00125 again?
That was from this calculation right here, the periodic payment. My R is at
got it.
1.5%. I've divided by making equal monthly payments. So that's my M at 12. So I'm dividing I'm dividing R by M, or 0.015 divided by 12. That gives me this number right here. This number just happened to be a nice number that terminated in my calculator. That's why I wrote it out. Normally I just wrote this over this right here and right here. But since it's nice, I'm gonna actually write it out. So we calculate this. Calculate the bottom first. I'm gonna do 1 plus 0.00125 is this. Raise that to the negative 18th is that. I'll do 1 minus that and get this. And I'll take the top, which is 0.00125, and I'll divide it by the bottom, which what I just calculated with that 0.022350245. I get this. And I'll multiply that by 1400. Here's what I get. So this says in order to pay that $1,400 loan off that you've taken out in 18 months, you need to make equal payments of how much money? Well, I need to make payments equal to $78 and 70 cents. $78.70 will pay that loan off in equal payments form in 18 months. Right? So the question is, how much interest will you pay on this loan? So how do we figure out how much interest I will pay on the loan then? Anybody help me with that? Without me automatically going out and outright telling you how to do that? Think about it in real life. Some of y'all probably have loans, right? Yes? No?
I'm gonna
Just me?
multiply the 7870 times 18.
Good job. Thank you so much. So I'm going to take this. I'm making 18 payments of this, right? So because of that, so I'm going to take the 78.7. I'm going to multiply that by 18 because that's how many payments I have to make of it. Here's how much I'm paying over the entire life of that loan. So I've had to pay, let me write this up. You pay 78.70 times the 18 months you're making that payment. That's equal to, you've actually paid $1,416.60. The TV itself, though, the loan that you took out was only worth what? Loan only equal 1,400. Thank you. Loan only equal 1,400. So how much am I paying in interest then? Well, your interest is just going to be that 1,416.6 minus the 1,400 that the loan was actually worth. And that tells me that I'm paying how much in interest? $16.60. Y'all okay with that, right? We understand how I did all that, right?
Yeah.
Yeah.
Again, the troubling part about all of this is not going to be, once you set up the formula, it's just a formula. You're following a formula. You need to make sure you follow the correct steps in the formula. The formula itself is easy. It's actually picking the right formula here. That's going to be the hardest part. And I need you to remember, when we talk about a loan, loans are always going to be present value. And so this right here is what we call amortization. And we call it amortization because what you're trying to do, you're trying to amortize. Anybody know what amortize means? Or anybody know what the root of what's in the root of amortization? What word's in the root of there? I misspelled it. There's too many M's in this word, by the way. It's only be one M. Anybody know what's in the root of amortization? What word makes it up? This is the root of it. Mort. Y'all know what mort means? Like mortal. You know what mortal means? Maybe not. Like Mortal Kombat. Death, to kill, those type of things. That's what it means. Mort means to kill. Amortization means you're going to kill the loan. That's literally what it means. You're trying to kill the loan. So in order to kill the present value loan, how much would I be making my payments to do that? That's what you're literally saying here. And anytime you talk about loans, or in this particular, we're talking about, like, for instance, your mortgage. Your mortgage is an equal periodic payment that you're trying to kill at a particular point. You're trying to knock it off, right? And one of the big aspects of amortization is mortgage. So you take out a loan to buy a house, monthly payments on a loan, monthly payments on that particular loan have to be made, right? To pay out the house in a certain amount of time. So look at this. Suppose you borrow. Suppose you borrow. This is the last example we'll do. This is what we call an amortization schedule. And you can actually make these for any kind of loan you take out. And in this particular schedule, here's what's going to happen. You're going to borrow a certain amount of money, right? And then you're going to calculate how much of the equal payments do I need to pay off this loan. So I'm going to borrow a loan, figure out how much are my equal monthly payments to pay it off over a certain number of years based on these payments. So I can figure out every payment over the number of years I'm doing it for. And I can also calculate, in particular, I can calculate what we call our interest and our principal, right? Our interest and our principal. So the smaller the principal, the less money you're paying in interest on it. This is the concept of how this works. And so when people take out loans, what they want to do is they'll start making equal monthly payments. But they always tell you, if you can afford more to put on it, you should put more on it. Because what you're doing is you're knocking down the principal. And as you knock down the principal, your interest starts to go down as well. Or the amount you're paying in interest starts to go down. And as you start to go down in interest, the payments actually start to go down as well too. So we're going to see that through the amortization schedule right quick. And so here's what it says. Suppose you borrow $1,000 and agree to repay the loan in 6 equal monthly payments at 1% interest per month on the unpaid balance. So you're at 1% interest per month. Now, I need to talk to you about this real quick. We're talking about 1% interest per month. This is totally different than what we've been doing, by the way. Because normally when I give you an interest rate, how do I word the interest rate? I give you an interest rate that is annual. An annual interest rate done like this, compounded monthly. Here I'm telling you, you're paying 1% interest rate already. I've already given you the periodic rate for this. I've already given you the periodic rate. Right? So construct an amortization schedule showing how much of each payment is used for interest, how much is used to reduce the unpaid balance, and the unpaid balance after the payment is made. So if you look, I don't know if y'all started, you probably haven't got the homework yet on this, but you look at your homework will be set up just like this as well. It'll give you these particular columns to deal with, right? And it'll tell you, we are borrowing how much money? How much are we starting off by borrowing? Can anybody tell me that?
1,000.
$1,000. So we're going to start in this first row on the zero payment. On a zero payment, we're going to start here, and we're going to start off with a balance of $1,000. We have to pay out this $1,000. In order to pay off this $1,000, though, the first thing I have to do is calculate how much are my payments going to be. Well, we just saw this is a loan. You're borrowing $1,000, so it's a loan. And we know how to calculate a payment for a loan. We just calculated the payment for a loan down here. So to set up the payment, we need to set it up like this. Your payment will be, how much am I borrowing? Well, we're borrowing $1,000 times. The top is your periodic interest rate, I. And this is what I mean by this is different. This says that you are paying 1% interest per month. This is already the periodic rate. Because normally when I ask you questions, I ask you about, and really it only happens when you talk about loans, or when you talk about mortgages, by the way, they actually give you the periodic rate. So when you talk about a mortgage, and this is an amortization schedule, they're always going to give you the periodic rate I. You don't have to go and calculate, is what I'm trying to tell you. Your I here is actually equal to 0.01. Because you're doing it per month. They've already given you your I. So the top of this is going to be 0.01. The bottom is going to be 1 minus 1 plus 0.01. And how many periods am I doing this for? Well, it says I'm doing it for
6.
Thank you so much. I couldn't find it. 6 equal monthly payments. So my -6. There we go.
I have a question.
I'm listening.
So basically what you're saying is because I is already broken down monthly, we don't have to do anything else.
That is correct. Normally when they say this, they always tell you annually. They give you the annual interest rate, and they'll tell you it's compounded monthly. Does that make sense? So when I give you the annual interest rate, that's the rate per year. But if you're compounding monthly, you have to divide it by 12. Here, they've already given you that annual interest rate. And they've done the compounding, they divided it by 12 for you, and they tell you it's 1%. But yeah, that's essentially what it's saying. So for this particular problem, we start off with a balance of this. We calculate our payment now. Our payment, the payment is equal to the bottom, 1 plus raised to the -6. 1 minus that is this. 0.01 divided by this is that. Multiply that times 1,000 is that. Here's the amount of the payment I need to make. 172.55. If I take that value, by the way, 172.55 and multiply it by 6, here's how much I'm actually going to pay. I'm actually paying how much in interest. How much do I actually pay in interest here? Can anybody tell me that? The loan is worth $1,000. I have to pay $1,035. I have to pay $1,035 and 30 cents. I'm paying how much in interest?
35.30.
$35.30. Paying $35 and 30% in interest, right? Here's how this is broken up then. We know that for the life of this loan, we're gonna have to make these kind of payments on it. Every year we have to make every month we have to make a $172.55 payment on it. So I can go ahead and fill that in for all these. That's what these are all gonna be. These are not gonna change. And we said this is $1,035.30. Okay with that, right? All I did was I filled in my payment column because I know I have to make a payment every month of $172.55. Now, here's how it works though. In a loan, what ends up happening is you're getting charged this interest rate every month. They're going to charge you this 1% interest rate every month. But what they're actually charging you the interest rate on is going to be this balance over here. So whatever you have left, they're going to charge you 1% interest on it. Well, notice that what's going to end up happening as you start to make payments, this is going to reduce the balance. And that 1% is going to be taken on a smaller number every time. So when we do this, we start off by taking an interest on the balance of $1,000. Well, 1% interest on $1,000. Anybody know what that is? You might not. 1% interest times 0.01, the I, that's equal to $10. So here is how much that I'm going to pay in interest. Right? That's how much I'm paying in interest. I'm reducing the balance here. I'm going to reduce my balance by whatever I pay in interest. I'm going to take my payment, this payment, and so I'm going to subtract out the interest from it. I'm going to take 172.55 minus 10 is this 162.55. This 162.55 right here is the reduction that's going towards my balance. That's the reduction that's going towards my balance. We call it principal. So look, let's talk about this real quick. I want you to understand what's happening. I'm supposed to make how much every month? How much of a payment do I make every month? Anybody answer that?
172.55.
Good, 172.55 cents. Everybody understand that? But is that full $172.55 going towards the reduction in my balance? Yes or no?
No.
No. How much of it is actually going to reduce my balance?
162.55.
162.55. So here, I don't have it written, but your final balance should be equal to the payment. Sorry. Your final balance should be equal to the previous balance. I don't know how y'all want to write that. I guess I'll write it out in words. Oh man, sorry. This is the previous balance minus the reduction R. So we'll say that's the previous balance minus the reduction R. So your new balance then is equal to 1,000 minus 162.55. And here's how much I owe in the next month. $8,837.45. So this is $837. And we start the process again. Right? So now look, I'm taking 1% interest on this number. I'm taking 1% interest on this balance, and I'm going to put it here. So 0.01 times 837.45 is this. So now I'm paying how much in interest? $8.37. What did you notice about the interest rate? What did you know about your interest now? Because you paid some of your money off, what happened to your interest? Your interest actually did what?
Reduces.
It actually decreases, right? It decreases. What's going to happen to your reduction on your principal now? Well, the reduction should increase, because now what are you going to do? Subtract 172.55, which is the payment you're making, right? That is the payment you're making minus the $8.37 that's in interest. And when I do that, I pay $164.18 in principal. That is how much money that is being applied to the actual loan to knock down the balance. So we do this, we get 837.45 minus the principal part, which is 164.18. My new balance of my loan is 673.27.
Okay, I have a question.
I'm listening.
So with each payment, the interest is going to be calculated by the current balance?
Yes, ma'am.
Okay.
That's exactly what's happening. Which means this, and this is a real life example, by the way. If you take out a loan, right? There's two ways to reduce the interest that you're paying on a loan. Because the goal is not to pay, you're going to pay interest. The goal is to pay as least amount of interest as possible. There's two ways to actually do that. The first way, the most obvious way, is to probably pay more than your actual payment. Because if you're paying more than your actual payment that you're making, you're actually increasing this when you start to take away the interest. You got that? That's one way. The second way, another obvious way, I guess, is the other way is to actually do less payments, try to pay it off quicker than what you're actually scheduled to do that. But the only way to do that is to actually increase these payment amounts. So it all focuses on the payment amounts. But you can make larger payments, right, to reduce interest, or you can do it quicker, which will reduce your interest. Those are the ways we reduce interest in real life. But we keep this up. Here's what happens next. Let's continue through this table. I'm going to take this number now, that's 673.27. I'm going to multiply by 1% again. Here's what I get. Now I'm paying, look, I paid less interest this month because I have less to pay on. Paying $6.73 in interest now. I'm going to subtract that from my 172.55 payment. I get this right here. 165.82. And I'm going to take that now. Look what's happening to your reduction. 162, 164, 165. It's increasing. I'm going to subtract that from the previous amount. Now I'm paying 507, 507.45. Keep this up. New interest, 507. Subtract that from the payment. $167.48. Principal went up again. Subtract that from the previous balance. Here's the new amount. Multiply by your periodic interest rate. Here's how much I'm paying in interest. It's 3.3. That's 3.40 actually. $3.40. I feel like I did something wrong there, but let's keep going. We'll multiply that by 0.01. This is $1.70, $1.71 here. 172 point, oh no, that's right. 55 minus 1 point. And look what happens here is when you do this, notice on this very last payment, I have 170.84. That's how much being applied to this balance, right? But I only need to pay how much here? 170.82. What have I done? I paid how much more in interest? Let's track this. This will be an actual, you actually have a net credit. You have a plus 0.02. It's supposed to be 0. Why didn't I get a 0? Can anybody tell me why I didn't get 0 there? Exactly.
Because you
Anybody tell me why I
rounded
didn't get
up
0
on
there?
the,
'Cause I've been rounding off a whole lot, actually. I don't even, I probably messed some rounding off somewhere. But you should be at the very end. Look what happened. You should get down to 0. If you add these values up in that column, let's add them up. 10 plus hands are too big. Plus 5.07 plus 3.40 plus 1.71. $35.28. That's where I messed up somewhere. That 2 cents should have went somewhere else. I messed that up. But how much was I supposed to get in interest? I was supposed to get how much in interest? $35.30. I'm pretty close to that. Do you understand that? This is a lot of error. I got round off error when I'm doing this. But this is $35.28, which is fairly close to what we were trying to get to. You're right. That's your total. You add these up right here. Plus 165, 2 plus 8 plus 169, 5 plus 170.84. That's the life of the loan. That should have been 1,000 in the very end. I just didn't do it. I had, like I said, round up error. That should be the $1,000 accumulating at the very end. So I don't know if you realize that what was happening. First time I taught this, I was like, wow, this is amazing. Because I didn't realize that this was what was happening. I thought you take out a loan, I know you had to pay more than what you were actually paying, but I didn't actually understand the structure of it. This is the actual structure of how you pay off a loan, by the way. You're making these equal payments like this, and interest is like this right here. If you want to knock down this interest amount, then what you want to do is you want to bring this payment amount up. Because what it ends up doing is that applies more to this right here. And remember, if you make this be big, it'll knock this down even further. That way, every time that you're doing interest on this, it's a smaller number. That makes sense? I hope it makes sense. It makes sense to me.